been a pretty busy day. All right, so I'll circle diagonally. 1 times 11x plus 8. Circle diagonally. X times 2x plus 5. Distribute, we get 11x plus 8 equals 2x squared plus 5x. And whenever it's x squared, you need to have one side equals 0. And it's totally fine if you wrote these vice versa. You can have the 11x over here and the 2x over here, no worries. The main goal is to keep x squared positive. So sometimes you're moving things to the left and sometimes you're moving things to the right. There's no exact perfect right way. Okay. Minus 8, minus 8. Okay, so the first 2 times I did this today, I did a times c. 2 times 8 to factor. And I did numbers that'll multiply to negative 16 and add to 6. But then, you got in. So, but then I realized there's a GCF. So if you want right now, divide both sides by 2, you can reduce all the numbers. Yeah, if they all divide by the same number, you can do that. 0 divided by 2 is 0. Okay, and then you're going to do what multiplies to negative 4 and adds to negative 3. Correct. Negative 4 times 1. So then we're at x minus 4x plus 1. Solve them both, and those are your answers. So now, if anyone has any questions about 1 through 10 yesterday, you can ask them, and if you want to turn in on paper, you can. Feel free to turn that assignment in on paper. I have some of your old papers you turned in. I'm going to pass back to you today. Yep. Oh no. All right. If nobody has any questions, I'm going to go ahead and put up the steps for our new problems today. Handwritten. If you don't want to write the steps, I suggest you go to page 712 and read it. This top sentence is a direct quote from page 712 about how we're going to solve these things. It says when a rational equation is not a proportion, so when it's not just the two fractions, you can solve it by multiplying each side of the equation by the least common denominator, which we really worked on before the quiz, figuring out what least common multiples were. So here's the 3 steps we're going to take for all of them. Step 1 would be to multiply both sides by the LCD. And then step 2 is a little bit curious. We're not actually going to multiply. We're going to write it like we're multiplying, and technically we are multiplying, but we're going to cancel out the denominators through reducing. We're going to reduce the fractions. And what will happen is the fractions will be gone. It clears fractions. A lot of people just call this clearing fractions. It's we'll leave you with a one-line equation, and then you just solve that one-line equation. So I'll leave this here for a few minutes. When everyone has had time to either read page 712 or look this over, I'm going to go to the assignment and I'm going to do the evens, and then I'll give you some time to do the odds. I'm doing today 17 to 23. And I'm going to do the evens. I don't know why I still have that, but that vocabulary is on the final exam if you want to keep it. Yeah. You gotta put out your name, date, period, and turn it in. This is a good try. What's that? That pile. I got that put in. I figured out which one it was, so you're all set. Can you pass this back to Mila, please? And that one's yours. That was yours. The students go all the way back to Adelaide. This goes all the way back to Jeanette. Can you take this all the way back? Reese, this is going to Jeanette behind you. This goes all the way back to Mila. This one's Mariah. Okay, are we ready? Is everybody ready? Okay, I'm going to leave this here and I'm just going to do it on the whiteboard. I'm going to do number 18 in this list of problems, and then I'll do 20. We'll go through these 3 steps. What I recommend is as these problems get more and more complicated, is that you use a piece of paper and you kind of spread it out. You kind of go the whole width of the paper. So I have 2 plus 3x. I'm putting a lot of space in here for myself. 1, 6, and 4 over 3x. Put a lot of space in here to do that first step, multiply by the LCD. Connor, what's the LCD here? Well, this means lowest common denominator. So if I was looking at these 3 denominators, what would I pick for a common denominator? I actually want to pick high numbers. I want to pick multiples. So remember? Yeah, you want to pick a number that all the numbers go into. So 3 goes into 6 and 6 goes into 6. And then since there is an x here, I'll include x in the LCD. So step 1 is to multiply both sides of this equation by the LCD. And so with distributive property, that pretty much means multiply everything. So I'm going to set it up here next to the first fraction, 6x over 1. And then I'm going to set it up next to the second fraction. And then I'll even set it up to the right next to the equal sign. You got that, Mila? You see it? You got it? If you see it now, it's going to save you a lot of grief in the next 2 days. We don't want grief. Okay, so that's step 1. Step 2 is don't actually multiply. We're actually going to reduce instead of multiplying. So I'm going to focus all my efforts on one fraction at a time. And I'm going to look up and down in diagonal. And if you remember when we reduced anything that's can reduce up and down or diagonal. So I look diagonally and I see these x's. I can cross x's out because it's a little multiplication problem. And 3 goes into 3 once, and 3 goes into 6 twice, so I can reduce that. So after you reduce, then you go ahead and multiply. So what I have here is 2 times 2 is 4 over 1. So that's just 4 now. The x is canceled. And then we'll do it again. Yes. Right, because it's a dot instead of an equal. Good question. Well, I'm going to do this here. Jacob, what are you going to reduce here? You guys close your Chromebooks, I guess. Yeah. I know. I'm looking just this little bit, this little tiny part of the problem. What should I reduce? The 6's, it's the same diagonally. And then also the 1's. Are you guys all right? What were you up to? Everything okay? Yeah. Oh. So then it's just x in there. So I'm down to 4 plus x. Bring down the equal sign. And then I'll reduce again over here. And diagonally, the x's cancel. 3 goes into 3 once, and 3 goes into 6 twice. And over here, I have 4 times 2, which is 8 over 1, which is just 8. And so it's pretty incredible that second step gets rid of the fractions completely, and you now have a one-line equation. The majority of the problems will have x squared here, so you will have to factor in all that. But it's nice to have gotten completely rid of the fractions. I actually did 6 divided by 3 diagonally. So you can reduce it, or you could think, well, 3 goes into 3 once, and 3 goes into 6 twice. So reduce those coefficients. Because the x's crossed out, and the 6 divided by 3 is 2 over 1. Yeah, so that's totally gone. And that's really what you should be questioning is where did these denominators go? We crossed them all out. And that should happen every time. The denominator should be able to cross out if you pick the correct LCD. All right, and then finish the equation, getting x alone, and you have your solution, x equals 4. And that's clearing fraction. Now I'll do 20. All right, I'm going to use this whole side. Again, I really recommend taking a lot of space to do it. It's not the type of problem where you want to try to squish it in. Students tend to get really lost in the process when they have all the numbers smushed in tiny. Especially 21. Number 21 is a long problem. 2 over x minus 3 plus 1 over x. Left a big space equals x minus 1 over x minus 3. Yeah. So step 1, multiply everything by an LCD. And I started saying this right before the quiz. This expression has to stay together. You can't like combine this with this x or anything. A lot of students are trying to make common denominators that are too small. If you're questioning, should I include something in a common denominator, just do it. Like if there's too much in here, the problem can still work out. But if there's too little, you won't be able to solve it. So I'm going to just keep in mind these are like little binomials. The x is independent, it's separate, it's all by itself. So I have to have x by itself and x minus 3. Both of those things have to be included in the LCD, not just x. Just put everything in there if you need to. All right, step 1, we're going to multiply all 3 parts by this. So x minus 3 over 1, x minus 3 over 1, x minus 3 over 1. We're not going to multiply. Step 2 says you set it up like you're multiplying, but you don't really start multiplying. First, reduce it. So we're going to focus on one little part at a time. Each one of these is like its own separate multiplication problem. And instead of getting to work with the multiplying, we reduce up and down or diagonal. In this case, diagonally, the x minus 3's can be crossed out. And all we'll have is 2 times x over 1. So that's just 2x. Nice. Just cross out what's the same. I'll do it again to this second fraction. What should we cross out, Aaliyah? The 1's, what else? The x's. And now all that's left is x minus 3. Everything was reduced. Equal sign. Focus on this last multiplication. The x minus 3's can cancel. And you're left with x minus 1 times x. And that will have to be distributed. So as the problem gets longer and more complicated, it'll be just like more and more distribution. It's the same steps. All right, so we did it. We cleared fractions. That's what's the good news about this whole thing is now the fractions are gone, and you're going to solve the equation. A lot of times just rewriting it. If it's x squared, set it equal to 0 and factor it. So I'm going to add the 2x and the x to get 3x and distribute. I don't want negative x squared, so I'm going to take the left terms and cancel them out to the right. Add 3. And we got 0 equals x squared minus 4x plus 3. And actually, I think one of these answers is going to get rejected. So we are going to get a false solution here. When we look and do a check, we're going to see that it doesn't actually work. There's 2 possible answers, and one of them is extraneous. Okay, so we got to do what multiplies to 3 and adds to negative 4. Yep, x minus 1, x minus 3. Make those little equations, and you get your 2 answers, 1 and 3. Now, which one do you guys think might be rejected? It's a 50-50 shot. It's got to be 1 or 3. The issue is, since day 1 in this chapter, we've been talking about what makes denominators 0. We don't want any undefined fractions. And so with x in the denominator, that's why we're open to that possibility. So think about which one, 1 or 3, would be a problem if you plug it into the bottom of these original fractions. Three is going to cause problems. If I put a 3 in here, 3 minus 3 is 0, and we can't divide by 0. Okay, so I'm going to reject it. Line through it. That one's called extraneous. That'll be either an asymptote or a hole in the graph. There'll be some problem with that. We're not going to go into all those details, but just know if you plug it in and it's undefined, don't include it in the solution set.